With gravitation, we can also say that we can look at something called a gravitational field. And so, let's say I've got an object here, like a planet or something like that. Okay, and it exerts a gravitational field. So that means that as I get closer to the surface of the planet, G becomes bigger. Okay, so let's take a look at what I mean by that. So if I'm out here, okay, G shrinks up. So if I were to draw that in terms of like an actual G, so here's G, here's G, here's G. So G gets smaller and smaller and smaller as you get further out from the surface of the planet. Now, just looking at one object, we can calculate the G, the gravity, just the gravity, and that's an acceleration by taking big G times the mass and then dividing by the radius squared. So guys, the radius squared, okay, now this can be confusing here, but the radius is radius of the planet, we'll say, or object. That's this distance here, from here to here. Okay, that's radius, okay, of the object. So let's just take a look at it for a second. If I ask you, and I say, and I made these the same size for a reason. If I say, where would I be if I were one radius above the Earth's surface? Okay, well, this is the Earth's core. This is the Earth's surface. One radius, okay, would be considered to be right here. So I'm going to call this, and you might see this in the homework, 1 RE. Okay, one radius of the Earth. Okay, and the other question is like, where would I be if I were 2 radii above the Earth? Well, right here, at this point, I'm 2 radii above the Earth, 2 RE. Okay, but don't forget that you've got to actually include the radius of the Earth in your calculations. So in here, if I say, if you are one radius above the Earth, right here, the number here would actually be radius of the Earth plus radius of the Earth. So in other words, if I say I'm one radius above the Earth, it has to equal the Earth's radius times 2. Okay, if I'm at 2 radiuses above the Earth, I am 1, 2, 3 Earth's radiuses away from the core, the center of the planet. Okay, so that becomes a little confusing as you're doing some of the homework problems. You may have questions for me on that, but once it's explained, it's actually pretty easy to understand. That if I say I'm 2 RE above the Earth, that means I've got a total of 1, 2, 3 radiuses to consider. If I'm 1 RE above the Earth, I have 2 radii to consider. If I'm on the surface of the Earth, I have the Earth's radius to consider. And the radius is measured in meters. Okay, so you're always going to keep that radius in meters. And you also have that number, I believe, available to you in the notes. I'm going to look it up for you right now. And so here it is, guys, and you might want to write it down. An Earth radius, so from here to here on the Earth, is 6.4 times 10 to the 6th meters. And then I also added in the mass of the Earth, and the mass of the Earth is 6 times 10 to the 24th kilograms. So you know you should be able to get the gravitational pull of the Earth. And what I'm going to do is I'm actually going to do that for you right now, just to prove that gravity is 9.8. So let's do this. Okay, gravity of the Earth. Now, guys, we know that's 9.8, but let's pretend we don't know that. All right, so G. I know what big G is. That's a gravitational constant. I know what mass is of the Earth. And I also know what the radius of the Earth is. So if I go forward with this and solve using G equals GM over R squared. Well, let me get some space here. G equals 6.67 times 10 to the negative 11th. That's our G. Times the mass of the Earth. 6 times 10 e to the 24th. Okay. And I take that and divide it by R squared. So 6.4 e sixth. And then I square that. Do that calculation and with a calculator, and you'll be surprised that G actually ends up being 9.8 meters per second squared. And we know that it acts in the downward direction, so I'll put a negative sign there. But yeah, that works out pretty well. Now, look, as I get further away from the Earth, okay, my gravity G is going to decrease. So on the questions, they might say, "Hey, you're up in an airplane at some height above the Earth." Well, don't forget, if you're like, let's say you're in an airplane right here, okay, right here, that's fine. That's fine and dandy, but you've got to include that plus that plus that in order to get the true radii, the true radius of where you're at. Okay. So this unit is pretty short. I am going to give you the week to do it and to do the quizzes. So you're going to have to do some reading in the notes. I'll also put some page numbers for you. That way you can double check your notes. Okay, that's it, and I hope everyone is doing well. Again, please reach out to me if you're having issues, okay, with the work, or even if you just want to say hi. I'd actually like to get a class meet together just to say hi, maybe just for a 5 or 10 minute meeting. So I may be posting that on Classroom, and I'm going to count it as a grade, so that way you're kind of compelled to say hi. Okay, we'll talk to you later.